good morning, everybody. I would like to welcome you all to 𝐴IM 2024. For all of you who are wondering what 𝐴IM is, accelerating innovations and ideas in manufacturing, which is part of SolutionBuggy's knowledge sharing session. We've been doing this year on year, and this year again we have had about 8 sessions, which will be covered in the next 3 days. Yesterday we had a session on food and beverage and nutraceuticals and on the chemical sector. The session for today is on exploring innovations in the electronics and semiconductor sector, one of the most awaited and booming kind of a sector in the Indian market as of today. A lot of demand as well as a lot of inquiries from entrepreneurs who want to understand this sector better and also see if there is an opportunity for a new entrant to get into this sector. So basically, we'll be looking mostly on the industry overview, what are the current market trends, and also finally a little bit on who are the key players and who could be the target market for us. Before I start, a quick introduction to SolutionBuggy. We are an online platform, like you all know, to connect the manufacturing industries with the experts. Today, we can proudly say that we are India's largest platform in the MSME sector, especially when you look at manufacturing. We have more than 12,000 plus experts on the platform. We have completed more than 3,500 projects across India over the last 6 years. And when I say projects, it could be anything from a one-day consulting assignment or a training program, or it could be lean consulting, all the way to setting up of an industry, right from concept to commercialization stage. Somebody comes to me saying that I have a land, I have some budget in mind, what can I do? So we start from there, the basic market research, product identification, new product development, then detailed project report, machinery procurement, plant setup, commissioning, supply chain management. It could be even technology transfer from other countries, mergers and acquisitions, and also in the sales and marketing development as well. A quick introduction. I am Guru Prasad Bangle, director at SolutionBuggy. I have 20 plus years of experience in consulting. I'm an electronics engineer and an MBA from IIM Bangalore. I am currently managing projects at SolutionBuggy. And like you all know, the reason of this webinar is mainly to give an understanding and the opportunities that an entrepreneur can look at in the electronics and semiconductor space. Over the next 90 minutes, I have 2 set of stellar speakers who will be taking us through this sector and talking a lot on this sector and throwing more light. Firstly, I have Mr. Sanjeev Keskar, who is heading Arvind Consultancy as of today. He's been in this industry for the last 20 plus years, holding positions of CXOs as well over his previous organizations. Over the last 4 years, though, he has been an independent consultant and also heading his company Arvind Consultancy. He's also part of the Ministry for Decision Making on the electronic sector as well. I welcome you, Mr. Sanjeev. Sorry.
Guru sir,
next, I have Mr. Wang, who is joining us from Taiwan. He is heading a company called Successful and Reliable Semiconductor Technology Services Company Limited. He's been working with us on a few projects in the electronics as well as semiconductor industry. It's an honor to have him here. We welcome you, Mr. Wang.
Hey, hello everyone. Good morning. Okay, thank you.
Yeah. So to start off today's talk session, I would invite Mr. Sanjeev to walk us with his presentation. Mr. Sanjeev, you want us to do the slide change, or will you be doing it?
No, I will share, Guru sir.
Okay. Okay.
Okay. Thank you, Guru sir, for the introduction. Good morning, ladies and gentlemen. It is really pleasure and honor to present at the SolutionBuggy platform. In fact, my association with SolutionBuggy is now for more than 2 years, and we are working on multiple projects together. And it has been really pleasure the way professionally they manage any technology partnerships or JV or M&A opportunities. And today, what I thought I will present you is the huge opportunity what electronics and semiconductor industry is bringing for all of us in India region, and also how innovation is going to help all of us. Guru sir, just before I start presentation, how much time I have so that
You have about 40 minutes. 40.
About 30 to 45 minutes?
Yes, yes.
Okay, thank you. So the topic, what we will do, we will go through this presentation maybe for 30 to 40 minutes, and we'll keep 10 minutes for Q&A.
Yes.
So I'm going to give you overview about the global semiconductor industry, which are the growth drivers. Then we'll come to India market, how India is looking over next 4-5 years. And then we will study the value chain of both electronics and semiconductor industry. And then what are the government of India policies for fabless semiconductor industry, as well as for semiconductor manufacturing, as well as for passive components and connectors and bare PCB industry. So this is the flow, and if you have any questions, you can interrupt me even in between, no problem. So talking about global trends in semiconductor industry, this is a report by McKinsey, and industry which was less than $600 billion in 2021, around $590 billion, and in fact in 23 the revenues have slightly gone down because during COVID time there was a huge supply and inventory built up. So but as per various forecasts, this industry is going to grow to more than $1 trillion by 2030. And this is not only McKinsey report, even all other research report talks about this growth of $1 trillion in semiconductor industry. And the key growth drivers to achieve this $1 trillion are going to be computing and data storage, wireless communication. We are going to witness 4G to 5G and 5G to 6G migration. Then automotive electronics is going to be a very big driver because world is moving to electric vehicle, and electronics plays a huge role into EVs. Industrial electronics, smart grids, utility meters, then consumer electronics, all home appliances and mobile phones, and finally the wired communication. These are some of the key growth drivers to take this industry to $1 trillion. Let's talk about India. Indian electronics industry, which was around $120 billion about the consumption last year, is going to grow to $300 billion. And in $120 billion, around $40 billion was finished good import and $80 billion was domestic manufacturing. With government launching this production linked incentive program, PLI program, we have seen in last 4-5 years, a lot of manufacturing has moved to India, be it mobile phones or any other industry. We have seen so many EMS companies as well as ODM and OEM setting up EMS manufacturing facility. And that growth is going to continue to almost $300 billion by 26-27. Talking about semiconductor market, typically semiconductor contributes 25% of electronics industry. So when I told you on previous slide that global semiconductor industry was $550 billion, global electronics industry was around $2.2 trillion. And when global industry will reach to $1 trillion, electronic industry will cross $4 trillion by 2030. So it's a very high growth industry, And even the semiconductor market in India is expected to cross $64 billion by 26, and by 2030 will be $100 billion. Talking about various market shares by component, processors and memory, these are the top two semiconductor components which gets consumed. Then comes connectivity, power and sensors. And talking about markets, mobile phone is number one. Then comes information technology, industrial electronics, consumer electronics, automotive electronics, telecommunication, and defense and aerospace. This is a report as per India Electronics and Semiconductor Association. There is a task force formed under PMO under the leadership of Principal Scientific Advisor. And I'm part of that task force, and we were trying to extrapolate, okay, with this growth rate, with our population, with situation between China and US, or with our relationship with Japan and Korea, how electronics industry will evolve in India, and what will be the impact on Indian semiconductor industry by 2047, when we'll celebrate 100 years of our independence, how this industry will look like. And by 2030, it will be around $600 billion of electronics and $100 billion of semiconductor. Whereas by 2047, it will be $4 trillion of electronics and $700 billion of semiconductor industry. We are talking about reaching a $5 trillion economy by 27, and ESDM, which is Electronic System Design and Manufacturing, which includes even the fabless semiconductor design, which include embedded electronics design, as well as component industry. All put together will be at $400 billion. So if we cross $5 trillion by 26-27, electronics industry plus design industry will contribute almost 8% of that market. And we have witnessed digital revolution in India. We have seen 1.25 billion Aadhaar enrollment. We have seen 1 billion plus bank account getting created, 1.2 billion plus mobile phone connections. And all this digital revolution requires a lot of data centers, a lot of infrastructure. Everyone is having mobile phones, smartphones. And that is really fueling the growth of electronics in India market. Another big advantage of India is our demographic dividend. We are a young country. You know, Europe is getting old, Japan is getting old, but India is more than 50% population is below the age of 30. And we are a young country, we can be global workforce. We have announced this production link incentive program, because of which a lot of domestic manufacturing has taken place in India. Infrastructure is growing rapidly. We have world-class airports, we have world-class road infrastructure now. And with Gati Shakti project and all the infrastructure project, it is going to help electronics industry in a very big way. And ultimately, our domestic market demand, with 1.42 billion population and more than 400 million middle-class population, our buying of electronics is going to be rapidly growing. Everything is becoming smart, everything is becoming connected, and so many IoT devices, so many GSM, GPRS connectivity modules, everything is getting trackers these days. So we will see a lot of Industry 4.0 driving, robotics and artificial intelligence, as well as IoT related applications. With PLI, we have definitely created a huge manufacturing infrastructure. But now the biggest challenge for India is how we can improve on the value addition. See, today, when we talk about mobile phones getting manufactured in India, Apple, Vivo or Oppo or Xiaomi or Samsung, all of them are getting CKD kit in India and doing only SMT assembly. So we get a value addition of only 10%. Till 90% value goes outside to import those CKD BOM, bill of material. And even in other electronics, be it consumer electronics, Samsung, LG, Sony, they bring complete kit to India and do assembly. Same case with IT hardware industry. They import PCB motherboard for processor, for laptop and desktop, and even all components are imported. So what India is ultimately achieving is 10 to 15% value addition today. Now imagine in a $120 billion market where 40 billion is finished good import and 80 billion is domestic manufacturing, but that domestic manufacturing of 80 billion is happening at 15% value addition. Actually, we are recognizing only $12 billion. In a $120 billion, India gets $12 billion, period. And that's the biggest challenge because our growth, as I mentioned, $300 billion is going to happen. But if we continue at 15% value addition, we will end up making less than $50 billion for our country. Still $250 billion will go out. And that's a very serious problem. Now, if we analyze value chain of electronics, 40% value is in components, 25% semiconductor, 10% passives, which includes capacitors, resistors, inductors, relays, motors, connectors, cables, and 5% is bare PCB. That's how 25 semiconductor, 10% passives, 5% PCB. Today, we are importing almost more than 90% of these components. So we don't get value of components. Next value is in innovation, IP, technology. Now we have great talent, but that talent is working either in a captive design center of a global company or in design services company. Means we have Intel, Qualcomm, Texas Instruments, Infineon, STMicro, Microchip, NXP, all of them doing chip design activity in India. Same way global electronics companies, Cisco, Juniper, Bosch, Delphi, Continental, ABB, GE, Honeywell, all of them are doing electronics R&D in India. But where is the local fabless semiconductor design ecosystem? We hardly have less than 10 companies doing fabless chip development. Or look at embedded electronics companies like Tejas Network or Secure Meter, very few companies. Most of the sectors like consumer electronics, mobile phone and IT hardware, we are still depend on the imported technology of global MNC. So we miss out on IP technology. We are getting jobs, but IP value goes to respective country. If Cisco is developing a router in India, IP goes to California. If Samsung is doing R&D in India for chip, IP goes to Korea. So that's the case with all the multinationals. And this needs to be changed. We have to make IP creation, product innovation from in India. Unless we do innovation from India, which is our strength, we will not able to capture higher value. So that's the need of the hour, that how we can create component ecosystem, how we can create IP and technology, so that today whatever value addition we are getting only with the EMS activity or manufacturing activity, that will change from 15% to maybe 40%, 50%, 60%. And then only when we will reach to $300 billion, we'll recognize $150 billion to $200 billion. So please understand the critical requirement of electronics industry today is how we can improve the value addition. Talking about the complete chain of semiconductor chip design till the electronic system, on top we have EDA tools and VLSI chip design. Then we have chip fabrication, that is called wafer fab. Then we have ATMP OSAT, which is called packaging of wafers to convert it into IC. Then we have electronic component and sub-assemblies. And finally, we have electronic product. This is a typical flow of any electronic system, right from chip design till the system design. If we analyze value chain of semiconductor, then VLSI chip design activity, verification and software development contributes almost 20% of semiconductor value. So when I told you last year $550 billion worth of semiconductor industry was globally, wafer fab industry was around $110 billion last year. And out of which almost 50% is Taiwan alone, with TSMC, UMC, Power Chip. All these companies are contributing to more than 50%. Then comes wafer fab, so I told you about wafer fab 20%, $110 billion. Then comes ATMP OSAT, which is around 10%. So last year, global ATMP OSAT industry was around $55 billion or $57 billion to be precise. Then comes component distribution. And finally, the profit margin in semiconductor is around 40 to 50%, depending on which industry you play, whether you are playing in memory or analog, the margins varies, but average margins are 40% plus. So this is a typical value chain. Now, VLSI chip design industry, that is our strength. We have great talent in India. We should focus on that. Wafer fab is an expensive affair. It requires $4 billion, $5 billion, $8 billion worth of investment. So it is the play of big companies like Tata, who have announced wafer fab in Gujarat. But ATMP OSAT, if someone is planning to set up a discrete packaging unit like diodes, transistor, MOSFET, then it doesn't cost much. You can do a discrete packaging unit less than $50 million. And again, I'm going to talk about the government schemes. Your real investment will be much lesser. And component distribution is growing because, we don't have local component hub like Singapore or Hong Kong. Today, all the electronics manufacturing in India depends on imports of component. And component distribution is going to be very big business because, as I mentioned, 40% of electronics is component. And we are importing more than 90% components today. So imagine if we are going to be $300 billion industry, our component market is going to be $120 billion, which is huge on any scale. And component distribution is going to play a very, very strategic role into supplying those components to electronic industry. Let's talk about Government of India scheme called Design Link Incentive. As I mentioned, that there is a critical need that we should create chip innovation from India. So government has come up with this scheme where if any startup is investing $4 million or 30 crore rupees into any chip design activity or semiconductor core development, then the startup will get 50% funding for design from government. That is 15 crore or $2 million, which is pretty substantial. And once that IP core or once that semiconductor goes into production, you will get $4 million or 30 crore rupees as a production link incentive. So if any startup is doing any semiconductor core development, they can expect 15 crore for design and 30 crore as a production link incentive. Total 45 crore rupees available under this DLI scheme. And in the task force, we have proposed that this $4 million or 30 crore rupees, it should not be flat across all silicon, because some silicon may be possible with 4 million investment or 30 crore investment, but some silicon may need $10 million, some may need $20 million. So incentive should be linked to the complexity of the chip. So we have recommended that this outflow of $120 million should increase to $600 million. And OCI or PIOs, which are our talent which is residing outside, should also be eligible for this scheme, which is not eligible today in the current scheme. About semiconductor manufacturing, there are three policies. First is CMOS semiconductor fab, where government is going to fund 50% incentive, but the minimum investment is $3 billion and above. So right now only one proposal is approved, which is of Tata's. Display wafer fab is for LED display, LCD display, or TFT display, or MOLED, which goes into your mobile phones, laptops, instrumentation cluster of automotive, or even your wearables like smartwatch. And there is a huge market for display. And again, the minimum investment is $1.4 billion, but government is going to fund 50% of that incentive. Third policy is compound semiconductor policy, where you have photonics, you have sensors, you have MEMS sensors or any other sensors, plus you can have discrete semiconductor, and all those products are captured, LEDs, RF, opto devices, they are captured under compound semiconductor fab. Plus the ATMP OSAT is also captured under compound semiconductor fab policy. And here also government is supporting more than 50%. Central government is supporting 50% for compound semiconductor project. And as I mentioned, if you go for discrete packaging, then the investment is less than $10 million or close to $5 million. So even a MSME can think of participating into ATMP OSAT, because 50% will come from central government, 20% will come from state government. So if it is a $5 million investment, you will get almost $2.5 million from center and $1 million from state. So ultimately you will be investing only $1.5 million. So these are pretty manageable projects. Or I think the minimum investment required is around $10 million in compound semiconductor policy. But still, $3 million is not a very big investment for any MSME. They should be able to do it. So very good policies. No other country in the world is offering 70% incentive for semiconductor manufacturing. So people should think of compound semiconductor project where even the discrete fab, it won't cost much. You should need a good technology partner who will not only give technology, but he will also buy back those components from you. So these three are very good policies, and if someone is interested, SolutionBuggy can support you in giving you the right solution idea, where you should invest and whom you should technically collaborate, as well as who will be your end customers. So there will be complete advocacy available through SolutionBuggy if any one of you has any interest of entering into compound semiconductor. I'm not talking about the SPECS program because the SPECS 1 policy got over on 31st March of 24, but SPECS 2 will be announced after the elections. Under SPECS program, they are going to cover all passive components like capacitor, resistor, inductor, relay, motors, bare PCB. And SPECS 1, they were offering only 25% of your capex investment. But I'm involved through ISA into SPECS 2 document. It will be much more attractive, like semiconductor policy. So once the elections are over, SPECS 2 will be announced. So please go through SPECS 2 document. In passive component, again, there is a very large opportunity because capacitors, resistors, inductors, relays, every smart meter requires 2 relays, and which cost almost $5. And we are going to produce 200 million smart meters over the next 3 years. So imagine $1 billion worth of relay requirement is there. And we are importing those relays today, 100%. Same case with small motors, BLDC motors, or same case with bare PCB. Imagine 5% of any electronics is bare PCB. Now, when we'll reach $300 billion by 26-27, our bare PCB requirement is going to be $15 billion. And the current domestic capacity is less than 500 million. So not even 10%, not even 5%. So there is a huge opportunity into even passive components, bare PCB, as well as in compound semiconductor. And through SolutionBuggy, we will definitely able to help you out into all these programs to get the right technology partner or right collaboration. So I will stop at this point of time, and I look forward to, if you have any questions, I'll be very happy to answer those questions.
Sure. Thank you, Sanjay ji, for a very succinct definition of the entire industry and giving us the last half an hour kind of a bird's overview of what the semiconductor industry has to offer. I think you have made it very lucrative and sound, that every entrepreneur today who is on the call should be interested in this sector. And the writing is also very clear. The government is giving us the PLI scheme, and then we have, such a big demand. Like you are saying, we are doing only 10% of the value addition as of today. So there is still a lot of, opportunities that are still not being met from the Indian players. And like you said, most of the IP is also not owned by the MSMEs or the Indian companies as of today, very few which you can just count on your hand. Companies who are from India and actually own these IPs. Obviously, wafers like wafer fabs, like you mentioned, is very expensive, though not something which a MSME or somebody with a lower budget can think of. But if somebody is really interested, then AT&T, OSAT, and components is something they can definitely look at. Huge potential, and also the market is pretty big right now. Not many players who are there in it. Even the PCBs, huge market potential, like how Mr. Sanjeev was telling. Lot of opportunities for technology transfer. A lot of companies from abroad who are looking for players in India who are bringing in capital and who are ready to set up shops in India. They are ready to give their technology. So having a good technology partner also makes a lot of difference in this. It's not just that we are lured by the PLI schemes. 70% almost comes from the state plus the central government put together. So the entrepreneur just puts in 30%, but that's not the end of it, right? So he needs a very good technology partner, and that's where it will make a big difference. Who is your technology partner? What kind of
No, you're right,
what does
Guru
he
sir.
brings to the table? Right,
When
right.
we collaborate or we get a mandate from any of the company between SolutionBuggy, then we not only suggest the right technology partner, but we do hand-holding till the JV partnership or a technology partnership agreement is signed, and we ensure that project is fully transferred, and we present a particular opportunity and also the JV partnership. We also talk about end market potential, what should be the differentiator, because there is you are going to compete with big Chinese companies on a price. So we have to have a differentiator. We have to have a strong technology partner, as well as we should have a potential customer. And so when I have seen, when we work sure that it is not only mere present customer who gives us mandate, but we do complete handholding till the time we give them a complete roadmap how the industry will evolve, as well as how they can expect the ROI on their investment.
Right, sir. So I think we have a few questions, although I won't be taking up all the questions right away, but just one question is this location agnostic, or do you suggest a particular location within India which could be good for setting up the unit?
Yeah, can you please repeat, sir?
Is location agnostic, or is there any state which is better than another state to set up a unit?
Okay. See, you have to look for two things. Not only the incentive part. Today, most of the states are offering 20% to 25%. Means Odisha is having maximum incentive of 25%. Gujarat is offering 22%. UP, Karnataka, Telangana, Tamil Nadu are offering around 20%. But my point is, don't just look at the incentive number. Look for what it takes for the supply chain ecosystem for that industry, what it takes for the water requirement for that industry, what it takes for the clean air, clean water, what is the power requirement, are you getting uninterrupted power supply that is required for that industry. Those are also equally some of the important factor, because if you're getting 25% incentive but your suppliers are located 2,000 kilometers away, then your supply chain will be spending a lot more money in getting your raw material. So my advice is look for the critical requirement for that particular manufacturing unit, and then decide which location is most suitable for you. Incentives, I think most of the states are offering 20% and above.
Right. Right. Thank you, Sanjeev ji. It was a wonderful session, but I'll ask you to please be on this session. We will have more questions that I will circulate back to you. Now I would call upon Mr. Wang. He's been very enthusiastic. As I see, he's been answering a lot of questions which are coming up already. Mr. Wang, it's an honor to have you here. Of course, you have taken time off your busy schedule, and considering the time difference that you're having, firstly, we welcome you to this session. Do you want us to pull up your slideshow, or will you be sharing it?
I can. I'm not sure. Let me try to share my screen if possible. Let me see. The whole screen, maybe here. So please let me know when you see the screen.
Yeah, we see it.
Okay, good. Thank you for the introduction from the SolutionBuggy CTO. It's my pleasure to be part of the Make in India policy. I've been have a very high interest in India, not only because of the population and the business opportunities, and also in person, I'm a fan of India food. As you may know, there are a lot of Indian people from India located in Taiwan, especially in Hsinchu. So that's good. And from my personal point of view, working with India, then we can bring the technology from Taiwan and other locations through my connections in this industry for 25 years, and also support India for growth, and as well as to make everyone make money, include myself and clients and SolutionBuggy. Some people say this is the comment which is too direct, but in my opinion, why we are spending time and the resources and using our connections to do the project is to make money. And then I will go through this presentation. Then if any question, please feel free to interrupt me, or you can accumulate a question in the end of the presentation. So I will make it quickly. So let me introduce myself quickly. My company name is SRSTS. It is Successful and Reliable Semiconductor Technology Service Limited. But however, the connections I can offer is not only in the semiconductor, but also include like the PCB and also the passive component, which Mr. Sanjeev just mentioned, and as well as the small motor. Because I had the experience to work with to provide the motor driver to the small motor company in southern Taiwan and also the middle Taiwan for a long time. But however, if you have further interest, please contact me through SolutionBuggy, because SolutionBuggy have been a very reliable partner since I've been working in the India project. Although I have multiple partners, including SolutionBuggy. Okay, so as a person for myself, I have been in Taiwan and working on the MPT, the manufacturing technology transfer for more than 30 successful cases already, and all of them are in high volume manufacturing. So one of the points I can offer is the know-how and the successful the way of work to make the technology transfer be surely successful, so that we can make money together. And also, I have the more than 80 reliable source of the manufacturing technology transfers called MTT. So, if you have any further interest in the technology transfer from Taiwan to India, check with the SolutionBuggy, or then we can discuss further. So Mr. Sanjay talked about the semiconductor ecosystem, the electronics ecosystem already, and I just repeat again. So as you can see, the whole ecosystem in the end is from EMS or the SI. SI means a system integrator, then to the end customer. But how the component come from? It comes from the IC design. I mean, for semiconductor wise, it comes from IC design. Then they generate a GDS. GDS you can consider is like a drawing of the circuit. Then they send to the mask manufacturing house, mask company. Then the physical, the actual mask are manufactured. Then sent to wafer fab. Excuse me, can you hear me?
Yes, perfectly.
Okay, yeah, it's good. Thank you. So once the mask is sent to wafer fab, it do the repeating process, maybe like a 20 steps, 30 steps, or even 70 steps. Depends on the complexity of the technology, but you can consider it's just repeating process. And if you have a further interest, then I believe you can find a good trainer in India. And if you want me to be a quick introduction, I can do that further. I'll do that later on. And you see there's two ways. One is the wafer goes through BGBM and the backside process. BSP stands for backside process. It's typical for the power semiconductor, power MOSFET, IGBT, and as well as the compound semiconductor, which Mr. Sanjay mentioned. Then it goes to the offset of outsource assembly and the test. However, for the devices that for like a general logic or like a memory, then they don't do this because they are like a surface current device. They just a wafer, then go to offset. They never go through the BGBM or BSP. Also, one thing for everyone's reference is that if we are talking about a diode, thyristor, or the rectifier, which is the vertical current, they need to go through the BGBM and BSP as well. And you may have a question. SI stand for EMS is a simple like Bara or the CANs in India. They purchase the component, they purchase the passive components, IC, connectors, cable, and the bare PCB, everything. They connect to become a finished product, then sell to the end customer or their customers as a subsystem. However, the SI is one of the key role then you may think about because the SI means that when okay, if I am the company, I want to sell the inductive heater. Then, however, I don't have knowledge and I don't have any R&D people. I have nothing. But how can I have my own brand with an inductive heater? Then the system integrator, as long as we tell them the spec, what kind of inductive heater I want, and the power, the power, and all the requirement, and also the price I want, then they will search for the components and give us a solution. Say, Mr. Wang, this is our proposal, and the minimum the MOQ, minimum order quantity is 1,000 pieces. Then we'll give you this quotation. And the system integrator is actually, it was quite popular around like 30 years ago in Taiwan. Then since around like 2004, 2005, it started like building up in mainland China. And a certain percent, I don't have a number right now, but I learned from the Avant and also the Workpiece. They are like an IC the component distributor, which Mr. Sanjay mentioned. It's around like 20-something% is they sell to the system integrator. So let me continue. And for the EMS, you can see they need a PCB for sure. They need a LED, connectors, passive component, battery, socket, and even more. And for the IC design, we need an EDA, intelligent property, IP, and the shuttle service, mask, reliability. And also, some people need an FPGA for verification purpose. As you can see from the job search internet, a lot of companies are hiring the verification and engineer, because when the circuit is designed, the first thing is to put into the FPGA to simulate if any design error. If not, does not mean everything is perfect. But if FPGA tells there's an error, then we have to come back to modify the design. Okay. So when we talk about the wafer fab, the BGBM backside process and offset, they need the EDA, IP, facility, equipment, parts and accessories, chemical, material, consumables, gas, the quality system, no matter incoming, outgoing, and in process, and reliability. And also there's a third-party laboratory, which I'll mention later. This is another investment opportunity. Okay, so let me assume everyone have no questions so far. Let me continue. So for IC design, we just mentioned about here. So this page I just skipped. For the investment opportunity, I will say, according to the experience and the intelligence we know from Taiwan and from China, which I believe can be applied to India in a certain level, we fully understand that India had, just like Mr. Sanjay mentioned, there's a lot of components keep importing from foreign countries, and mainly it's actually from mainland China. So, as far as I know, like a PCB is 90% imported from mainland China, and for IC, for the semiconductor itself, the finished goods is also, if we include like Hong Kong as a part of China, then around like 60 to 70% is imported from mainland China, which I personally believe India should stop spending the foreign exchange to the importing the devices, because most of the devices India can can do the local manufacturing through the support from expert like us, and also through SolutionBuggy. So let's focus on number one. Let's do the imported high volume devices, and everyone has to use every single day, no matter the people they are rich or they are poor. They have to use that every single day. They have no choices. Okay, and also I know some people may not agree with my point number 3, but from the less complexity design and very easy for pin-to-pin replacement to like a Infineon ST Micron, the Renesas or the ROM or whichever, pin-to-pin replacement is a very important key. Otherwise, if the user means the EMS or the system integrator, they need to change the design again. It's too troublesome, and most of the time they don't want to do that. So less complexity in design, circuit design, and also the easy for pin-to-pin replacement is important. And also for number 4, this is the general practice as far as I learned, but patent violation is always a problem. But in India, then we will manage that for sure through the cooperation with the SolutionBuggy. So the suggestion from my company is I will suggest India to invest the client. Then you are I know the clients everyone are listening right now. Then the recommendation from our side is to invest the power MOSFET, IGBT, gate driver, and diode, because you can see the orange color here is the basic elements of the electronic system, and as well as the like a basic component and also others. However, from semiconductor point of view, these are like we should invest, and also like a driver IC for display, LCD, LED means included OLED, organic LED, and also like the RFID, and also the content is chip, because everyone in India may not have that right now, but sooner or later it will become one or everywhere in the world. If we have one car, we buy things, we take the MRT, we take the bus, just we don't use cash. So this is another thing we can do. Yeah, all right. So for IC design, this is the step-by-step business model suggestion from our side. Number 1 is for the investment. Of course, we have to establish the IC design company. However, my suggestion is to form the IC design company, we must have a very strong relationship with the EMS, or at least with the system integrator. So in China and Taiwan, some of the design company actually is owned by the EMS or the system integrator, as you can see from the Foxconn or the ASUS, or they are investing a lot of IC design companies. So the first step in India is we have the India IC design company established. However, first step is to get the finished wafer from Taiwan or from Japan or from somewhere which are reliable and also market proven. Market proven means they know where to sell already. And we send the wafer to the offset in India to fabricate the finished products. Then we sell to the EMS SI or sell back to the original the company. Second step, this one can ensure we have the positive cash flow, and we will know how to operate the IC design company step by step, and as well as the offset, because manpower or the human capital is always the key point of the company operation and growth. So the second step is through the first step, we can test, we can evaluate and verify the end market, where is the end market, and is good enough for our investment for the return. So we can get the third party GDS. Because everyone say, oh, the IC design is very easy, very simple, everything computerized already. But frankly speaking, my experience is for the the power MOSFET IGBT is not as easy as imagine, because too many trade-off and the tricks. Then it's never on the paper, never in public. As you may see the news, the comment from TSMC. TSMC is the largest wafer foundry in the world, which I worked for TSMC in the past. 80% of the TSMC knowledge is never been in the patent or in the paper. 80% is their trade secret, okay, or know-how. If you never work in TSMC, you never know that. That's unfortunate. That's the truth we are facing. So we know the finished wafer purchase are reliable, and we know where to sell, and with a proven market size. Then we get the GDS from exactly the same company, and then we manufacture the mask in Taiwan. The reason is, we can see the blue one means in India, and the green one means in Taiwan. The reason is because the mask house will spend a lot of time to put into production and also accepted by the wafer fab. So I will say mask house is like the little brother of the wafer fab. So we purchased the India IC design company, purchased the GDS, and made the wafer mask, fabricate wafer in Taiwan as a second step through the BGBM or backside process in Taiwan as well, and do the offset in India. And this one is the like intermediate step, which I don't want it to be continue for a long time, because it is not good for our for India, and not good for everyone, including myself, to collect the money accordingly. So the step 3 is we still purchase the third party GDS from Taiwan or Japan. However, we fabricate a wafer still in India and make the BGBM and the backside process facility in India, because this one is not complex. And if you have an interest, we can have a different section a couple days later. I will explain in more detail. Because the BGBM and the backside process actually can combine with the offset, and this is the most important, one of the critical part of the power MOSFET, IGBT, and the diode reflector, the reflectors, thyristors. Okay.
One question here.
Yes.
What is the market that an entrepreneur can look at? Is it the local Indian market only, or should he be looking at the export market?
Okay, this, according to my understanding, that we can focus in India local market first, because India has 1.4 billion populations. And imagine that if everyone, because okay, for example, like the smartphone we are using every day, there's a lot of MOSFET inside. It's a smaller MOSFET. And for the IGBT, do you know where they are using? Like a photovoltaic, they have IGBT. The electrical vehicle, you have IGBT. Even every everyone had to use that as a water pump. No matter we are living in the apartment or a community or in just a standalone house, as long as we are using the pump, then you need the IGBT every single day. And imagine how many pumps will be required for India. And also, please remember the IGBT module in the pump is like more like a consumable, but it will be replaced in every like 5 to 7 years. This is the reason I'm the recommendation from us. It starts from there, because no matter you are the rich man or the poor man, as long as everyone need to use that semiconductor or the PCB every single day, it's like investment worthy project we should go. This is the recommendation from my side.
Right.
Yeah. So can I continue?
Yes.
Yes. One of the reasons in step 3 to keep using the wafer fab in Taiwan is because the wafer fab, there's a lot of know-how about wafer fab. Like people say, oh, I have a circuit design, I can switch the wafer fab very easy. No, it's not. Wafer fab have their own fingerprint. So actually the name is called the process characterization or the process fingerprint. So the design need to fit the wafer fab exactly. Otherwise, we switch to another wafer fab. It takes at least 1 year. In my expertise, it need 1 year, or sometimes it go up to 2 years. So the reason to do that in the step 3 is because we are here to make money. So using this route is almost the guarantee way to ensure the cash flow is always coming. Okay. However, keep using the fab outside India is not a good idea, because wafer, as Mr. Sanjay mentioned, we need to increase the value chain and the value occupation in India, which means we can collect more money. So in the end, we will do everything in India. However, frankly speaking, I'm not sure how long it will take. It may take like 2 or 3 years, or even 4 to 5 years. But surely I will be part of that and make sure everyone's success. Okay. And the last step is we do the manufacture 100% from silicon to system. Everything in India through the technology from Taiwan. However, the people in India are so smart, and I've been working with a lot of people, my colleagues and co-workers from India. All of them are very smart. So I believe India have a very bright future in the coming 8 to 10 or even longer years. Okay. So then let's do the breakdown. This is the IC design section. Any questions? Let me stop here.
I think we will take the questions at the end, Mr. Wang.
Yeah, you can call me Yumin or call me YM. No problem.
Okay.
Yeah. Because people in my friend they just call me Yumin or call me YM. They rarely call me Mr. Wang, but it's okay.
Okay. Sure. Sure.
So for the strategy here, first step, purchasing the finished wafer from Taiwan. Then I have a lot of companies in Taiwan. Because why? I believe you are wondering why. The reason is because most of the IC design company in Taiwan is around like 20 to 50 people. They are not huge, and they are not capable enough, or their manpower is not big enough to handle the market in India or even outside Taiwan. Most of them, they focus in like Taiwan, China, or United States, Europe, Japan. That's too much for them. So I talked to them for more than around like 1 year. So they are willing to sell the wafer to India and use the India local offset, which I will mention about that. We'll talk about that later. And the third-party GDS are from the same companies. They are also willing to do that because from their point of view, they keep collecting money and just let me enjoy the profit share, but they can expand the income and the revenue and also profit significantly without paying too much resources and efforts. One of the reasons is because if they hire people in Taiwan, it's not easy to proceed the layoff. So they prefer to work with like an independent consultant like me. Okay, like the company like my company. So first step, purchase the finished wafer. Second step, have the GDS. And third step is doing the BGPM in India. This is quite, I would say, compared to wafer fab and even compared to the offset, BGPM and backside process is even easier. Okay, then everything in India eventually. And also one thing I should not say here, but if you know how China, they are doing. I mean, the IC design company in China, they are doing to collect the government subsidiary. For something that this is the public domain, I cannot speak too much, but please remember the step 1, 2, 3, 4, 5. Then you, if you have any further question, please contact SolutionBuggy and have me in the loop. Then we can discuss separately. I will share much even more, which I cannot do that in public. Okay. So this is the end of the IC design. Any further questions?
No, Yumin, you can go on.
Problem. Then let's move to the wafer manufacturing and the BGPM backside process. As Mr. Sanjay mentioned, the wafer fab is actually very expensive. So I do not recommend you to move into the wafer fab. However, there's all the rules always have the exception. The wafer fab that you can consider is the wafer fab for diode and the thyristor and the rectifiers. The reason is because the investment is it's not too far from the offset, and every single component, everyone in India unfortunately has to use the diode every single day. And I do not put the diode introduction here because it's too much. But the diode is a very good business. Although the single component itself the price is very low, but there's like hundreds of billions diode to use every year in India. That's my belief. Okay. And wafer fab and the BGPM, I would say let's establish the BGPM and backside process facility in India and partner with the power MOSFET and the IGBT IC design companies, as well as the OSAT. And Mr. Sanjay mentioned that about the compound semiconductor, they also require the BGPM and the backside process. So you can include it. Sorry for I didn't consider the compound semiconductor in the beginning because right now China is they are doing the investment like crazy. And the suggestion, the recommendation, I talked to my friends in Taiwan is just put on hold and let the bullies and keep flying. After a couple months or 1 or 2 years, then we can see. Okay, and when we have the BGPM facility and also the OSAT and also IC design, then one critical component in the whole ecosystem is required. It's the third-party laboratory for material analysis, then reliability analysis, failure analysis, and one of the CA is interesting is a competitor analysis, because a lot of design company in Taiwan they are always asked by the system integrator or even the EMS like a Foxconn or the ASUS. Here is the component I get from the tier 1 company in the world, but it's very good and very expensive. So most of the time, the first group of the products are always using the component from tier 1 company globally. But due to the price erosion pressure everywhere, anytime, they need to change to the less expensive, or we should say cheaper components day to day, time to time, quarter to quarter. So what to do? They just give the components to IC design company like me. Then Foxconn or ASUS, they say, I want to have the pin-to-pin compatible stuff in 6 months. Then what can I do? first thing I do is always read the data sheet and get the actual chip and do the reverse engineering through the competitor analysis. So, and this one, you may hear the company name called Martech, IST, and also the MSS. They are the very famous third-party lab in Taiwan. And if you have interest in cooperating or setting the joint venture with them, I can help to connect to their CEO or chairman. Then, because they also have interest in India. However, they don't have experience in like managing stuff in India. Then they are still considering. So this is a good investment opportunity. We can work together. Okay.
Assuming I would want to ask a question here.
Sure.
Say you are having a lot of technology sources and partners. So just to help the audience here, what are they looking at from an Indian partner?
What kind of, what's the last sentence? I'm sorry.
No. What I'm asking is if you can tell one or two key points which your technology partners are looking at when they want to come to India. So what are the key things that they will be looking at from an Indian partner?
Oh, I see. Please forgive me. I just go straight. They have two major concerns. Number one is they don't have the technology source. They are very good in technology and also they want to collect the money. However, 2 points they are not comfortable. Number one is they don't have the experience in managing the people in India locally, because I know there's a lot of rumors or a negative image about India in like Taiwanese or somewhere. I don't want to tell that too much because it's not for everyone. But it's a general image in Taiwanese is people in India is very difficult to manage, and cheating is the more severe than in Taiwan, because in Taiwan if people cheat, it's not easy to survive. But India have a 1.4 billion population. If they have some problem, they can just disappear and change their name. However, people in Taiwan, we cannot do the detect. We cannot hire a detective to do that. So this is one of the reasons they don't want to invest India for now. And number two is the payment collection is always a problem, because of my I have a couple projects ongoing. Unfortunately, my first project, I completed the project in around January, and I still do not get the payment yet. And I keep receiving the request and make a discount, and it just never ends. So this is the two major points. Number one, management in India as a local company. Number two, the payment collection. This is a major concern from my technology sources in Taiwan, unfortunately. Sorry, please forgive my just go direct.
No problem. No. So that is where I think a reliable partner like us can get the right people onboarded and make sure the handshake is done between the Taiwanese company and the Indian entrepreneur, and we definitely will be able to bridge that gap. So that's something that we want to give an assurance to you and your company.
Yes, and this is also one of the reasons I keep a very strong connection with SolutionBuggy. Because the SolutionBuggy is a good interface to help me to eliminate these two concerns in front of my the technology sources, and also my friends, they are asking, you mean why you do not just go direct? As long as you go direct, you collect much more money than through the SolutionBuggy or other India partners. I said, from the mathematics, is correct, but from the business acumen and the insurance point of view, it's wrong. Because collecting the money, I cannot do that. I am not Indian, and we have to rely on the trustworthy partner in India, like the SolutionBuggy. So this is the reason I prefer to earn less, and I told them they should also earn less. But through the trustworthy partners, we collect much more projects, which means if we want to go direct, I may be able to handle only one 6-inch pizza. But if we have a correct partner, we can fabricate a 30 inches pizza, and we share the piece of that, and the whole area is much bigger than one single 6-inch pizza. This is the concept. Okay. Yeah, that's all the answer for these questions.
Sure. Please go ahead.
Sure. Okay. So let me continue. Then when we
have about you mean we have about 15 minutes more.
Fine. No problem. Let me speed up. So when we establish everything, like number one, the third-party lab, then we can think about it as investment opportunities for the clients, for our clients in India, like users. Number two is we should consider to upgrade India's existing manufacturing capability for high volume. I call �MEPA. �MEPA stands for material, chemical, consumable parts, and accessories. Because building the main equipment, we should not do that in India. It's very deep to like land research, applied material, SML, and the other people in the world. They've been doing it for a long time. But parts, accessories, consumables, chemicals, and material, we have to use that every single day. Then it doesn't make sense to import it from outside. We should do the India local manufacturing for long term. Okay. So for like the imported high volume items, existing facility in India, we have that already, then we can upgrade. If you have the existing facility for like a H2SO4, NH3, then H2O2, hydrogen fluoride, TMH, ammonia, and something, then let's talk about the local manufacturing through the upgrading the manufacturing capability and capacity. And also there's a ceramic parts, O-ring, pump, valve, wafer cassette, silicon wafer, metal target, like polymers, the mask blank. Then I'll talk about it later, and also the substrate material. So many things. I don't go through one by one, and I believe you will get my this PDF through SolutionBuggy.
Yes, we are going to share the PDF.
Yes. So if the clients have specific topic we want to talk about, then we can have a different section. I will spend more time and more specifically to talk about it. Okay. So let's wafer part. Actually, for OSAT is the same. It's very similar. Okay, like a leaf frame. I'm not sure if you know this information or not, but for leaf frame based IC, the leaf frame can occupy around like a 40 to 50% of the cost for the whole OSAT. So leaf frame local manufacturing is mandatory. And luckily, I have two friends. They are the chairman of the different manufacturing companies. They have an interest in India as well. And also the substrate. Substrate is important for BGA. And also the epoxy, wire, so many things. Okay. However, for OSAT, there are so many choices. Which one we should consider? Phase one, let's focus on very high volume items every single day. Let's do the COB, chip on board. So what the chip on board stand for? Chip on board is I have some slides. Where are they? I deleted that, unfortunately. Oh, that's okay. The chip on board is when you open the toy or like the USB drive, you will see a PCB board with like a black dot on it. Actually, underneath is the IC with a wiring on the PCB board. They just put a resin as a assembly. So easy. That's very cheap. And the toys or the low price electronics is almost everywhere. Or even some middle price items, they also use a chip on board. I don't know why, but that's very cheap and high value. They have a huge market in India, and technology-wise, it's quite simple. Second one is the first one, chip on board, power MOSFET and IGBT, and as well as the LED, diodes, rectifiers, transistors. those things, unfortunately, everyone in the world, no matter in America, in India, or in Taiwan, everyone had to pay the money for that every single day. That's why we should do that. And for QFN, we can start from for more like a small scale manufacturing, because QFN will be the key to phase 2. Because QFN is widely used everywhere for the more complex devices. So phase 2 will be the QFN stack die and BGA. And if you want to invest more, then do the BGA stack die. And also the MEMS. MEMS have the actuators and also the sensors. Then we also use that every day. Imagine that in the smartphone, how many MEMS we are using? A lot. So this is the something we can put onto the investment list. And people, I believe a lot of people, because I have been working with a lot of people from India, they are always asking me, where is the CoWoS? Where is the advanced packages? Where is the something fancy? But I always told them, please do not consider the CoWoS, because unfortunately, CoWoS is part of the very advanced node wafer manufacturing. If you do not have the advanced like a 10 nanometer, 7 nanometer, 5 nanometer wafer, if you cannot get a wafer and you cannot have an order from customer, you have the CoWoS, that you never get a business, unfortunately. So the recommendation is that let's leave the CoWoS to wafer companies like TSMC, Intel, Samsung. We should not touch that for today. Okay. And meanwhile, as I just mentioned, we can consider to have the wafer manufacturing for diodes, reflectors, and transistors. This is the typical path Taiwan and China to get into the market. Because Taiwan, when I was an elementary school student, by the way, I born in 75, so I'm almost 50 years old. In around like 40 years ago, I live in Kaohsiung. And in Kaohsiung, there was a very famous import, they import the material and the assembly and the export. So a lot of companies in Taiwan today, you may not know the history. They are actually from the distributors. And then time to time they realize, oh, the assembly is the offset is not as difficult as they are imagining. So they build an offset. So in around 30 to 20 years ago in Taiwan, there's around more than 70 offsets in Taiwan. But time to time, the people, the founders, they got aged. They don't want to run a business or whichever. So it keeps shrinking. However, the history path is the distributors, then offset, then they purchase the wafer from outside. Then they get moved into the wafer fab for diodes, reflectors, stylistors, transistors. And one of the company you may hear is the Penji in Taiwan. They are quite famous. This is also the reason.
What's the name? Sorry.
Penji.
Penji. Oh.
Yeah, but anyway, if you have interest, we can talk about it separately. And sure, this is the reason I am talking about in the IC design, the 5 steps. 1, 2, 3, 4, 5. Because this is the proven path in Taiwan and in China already. A lot of the companies in China, they also start from the distributor, then get into the offset, then import the wafers and sell to their channels to SI, system integrator, or the EMS. Then they move into the wafer manufacturing for this kind of a low technology but huge volume, huge. So this is also another investment opportunity we can consider. And please allow me to make the advertisement. All the technologies until right now are all ready. Then as long as we have the engagement, then I can introduce the technology partner to discuss and start the technology transfer right away. Okay. All right. So last thing is the PCB.
Just a small announcement, Blooming.
Sure.
For the people who are on the call, there is a small poll that has come up on your screen. Kindly answer it, and we will continue with the session.
Sure, no problem.
So it will just take you 5 seconds to answer this poll.
So can you repeat the questions?
So Yu-Ming, this is a poll for the people who are on the call. So they need to answer the questions. Yeah, you may continue now.
Okay, sure.
Yeah.
And for the PCB, yeah, they have a rigid PCB, rigid and flexible PCB, rigid, flexible, and also IC substrate. Then I don't talk about it in details because we don't have too much time. However, there's a lot of companies. Actually, as you may know or you may not know, the print circuit board technology in mainland China are actually transferred from Taiwan to China through Taiwanese, and I know some of them, and they are waiting to transfer their technology to India. That's because they are around like the age of the 60 or even some are almost 70 years old, and their kids, they don't want to step into this hardcore business. PCB is really hardcore. You spend a lot of time and a huge volume, so operation and people management are quite difficult to the second generation from the rich family. And that's the reason I can get the technology which we can transfer to India. And for the investment opportunities, I will say phase one start from the less complexity, like a less than 12 layer PCB, and we purchase the equipment part, everything from Taiwan. It's because to ensure the manufacturing is stable and repeatable. However, this is just a pilot line scale, and we extend to more. We do that locally in India. We will provide the consultancy to make sure your success. Okay. Then also the importance in phase one is through this kind of the less complexity manufacturing, we can hire the people and convert who are capable to move to the next phase. So the next phase is the much higher layer PCB, and we start a local manufacturing for the parts, consumables, chemicals, and everything in India. Then I can also connect the source as well. Let's determine the scope later. And also I know the HDI, high density interconnect PCB are also required because one of my another connection, they are asking for that right now. The reason I got is because India have a lot of the smartphone assembly business. So HDI is widely used for smartphone and mobile devices. So this one we can also discuss. And substrate for BGA and advanced package, then we also offer that as well. However, let's do that one by one, because one last thing I want to highlight is when we say I want to buy a car, then what kind of car we want to buy? So many, right? And even I say I want to buy a truck. Come on, we have like a 30 or 40 types of truck. Then I say, okay, pickup is easier, right? Unfortunately, we have 4 types of pickup, and even more. So when I talk to SolutionBuggy, I always ask SolutionBuggy to confirm. Number one, what are the expectation and the requirements from client to be specified? Otherwise, it will become something like that. Okay. And number two is we will share the recommendation, just like I shared in the past 20-something minutes. Right. And even more detail, I have that on hand already, but it's up to the further discussion. And also the market selection and launch customer engagement is very, very critical. I cannot provide the launch customers to you in India because I don't know the India too much, and I come on SolutionBuggy to connect and also to collect the money. But I want to make a highlight. All the successful technology transfer I've been working with, I always keep asking for who are your launch customers. That's super important because in the launch customer ensure a couple of things. They told you what they want. Then when we manufacturing the goods, we can sell and convert into money. And number three is usually the launch customer, they are or like a bigger volume, and also they are the tier 1 or tier 1.5 in the market. So working with the large customers and make it then successful, we success as well. And meanwhile, we get the credit in the market. Then I work for Intel. And then people come to us, Intel certify you. I don't have further question. Something like that. All right. Sorry for I keep speaking quite fast, and also apologize for my Taiwanese accent. But any further questions?
Thank you. No, it is wonderful to have you here and understand a lot of perspectives from your from Taiwan, and what are they thinking, and also what is the kind of opportunities that an entrepreneur in India has to tie up with the Taiwanese firm. Thank you, Yu-Ming, for a wonderful session. Just before I leave, there is a question. I'll just paraphrase it. It is something like, why will not somebody use a Taiwanese imported product, and why will they go for manufacturing within India, and is it going to be more competitive in terms of pricing?
Okay, this is a very good question. So the technology from Taiwan, if we are talking about the unit price, is not competitive at all, because most of the except the OSAT and the wafer manufacturing in Taiwan, they are huge. So no one can compete with the Taiwan, especially like a TSMC. When you may hear about the 𝐿𝐿𝐺𝐶, have anyone hear about that? 𝐿𝐿𝐺𝐶.
So what is the name?
Out of Greater China, or we can call it much easier, non-China. So I am the consultancy of a couple companies right now. Their customers, like they say DHL. It's not the delivery company. DHL is for Dell, Lenovo, and HP. Like a Dell and HP, they are asking for components which is not China made, because of the geography politics issues, as we know. So the Taiwan made is always like engineering samples or the low volume manufacturing. The high volume always move to China or Philippines or even Malaysia or Thailand. However, what we are asking for is the technology, right? So the technology here I will transfer is we ensure, number one, the capability of expansion is a very strong, solid, and also quick, fast. Because the cost is actually controlled by the size in India eventually. If for example, the PCB is just like a 100 square feet per month, how come the PCB can be cheap, right? But if the PCB is like a 5 million square feet per month in India, then the price can be very low. Plus the local, the material, consumable, everything India local made. So I want to make the further comment according to Mr. Sanjay's the pyramid. There's a vertical, and in parallel, please remember all the material, chemical, consumables, parts, gas, everything. Then you should do the India local made, and those things can be made build up very, very much easier, and so that you don't need to import from Taiwan or from China or from somewhere, because we are paid a lot of money for transportation, which you should not do that. And I believe India had the infrastructure industry, like chemical industry, and also the dye manufacturing. Dye means like a color of the clothes. Then you can convert a facility into this kind of manufacturing not very easily. Okay.
Perfect.
So this is the answer for everyone.
Right. Thank you. Sanjeev, one question for you. Sanjeev, can you hear me?
Yes, sir.
Sanjeev, yeah. So one question, I think you already mentioned this. What is the ROI of this industry? You mentioned it can go up to even 40%, but can you give some more insights into it?
So typically there are 3 to 4 types of sub groups we can have in electronics industry. As I told, semiconductor manufacturing, that is wafer fabs, and also semiconductor design, that industry gives around 40 to 50%. ATMP OSAT is slightly lower than wafer fab because it is a sort of a job work OSAT where you are packaging the semiconductor. That is around 20 to 30% of EBITDA. Whereas if we go with EMS activity, electronics manufacturing services, then it depends on what type of products you are producing. Are you doing aerospace defense? Are you doing industrial electronics? Or are you doing mobile phones and consumer electronics? Based on the product selection, the EBITDA varies from anywhere between 5% to 15%. Because it all depends upon the volumes and totally, are you doing job work or are you doing a complete kit buying and doing turnkey project? So it all depends on what type of job work you are doing. Are you sourcing components? So in EMS business, it is around 5 to 15. In ATMP OSAT, it will be around 25 to 30. In wafer fab and VLSI chip design and semiconductor manufacturing, it will be around 40 to 50.
Perfect. So thank you. So I think we do have a few more questions, but since we have run out of time, I would circulate these questions with the experts. I'm sure over the last 90 minutes, it has been a wonderful session with Mr. _𝐤𝐚𝐫 and Mr. Sanjeev Keskar. We have learned a lot in this sector, but as I said, in 90 minutes, you can just scratch the surface. You can't learn completely about an industry, but I'm sure it has opened up a lot of avenues for us to go and research and then come back and ask the experts whatever we want to know. We definitely enjoyed having both the stellar speakers on the session, and also thanks to all the participants for being a wonderful audience. I'm sure you'll have a lot of queries. You can write back to us. My team also will be contacting back to you. And with that, I would like to end this session and thank all the participants and the speakers for their time and effort in spending the last 90 minutes with us. Thank you, Sanjeev ji, and thank you, Mr. _𝐤𝐚𝐫.
Thank you. Thank you.
Thanks to all the audience. There is a next session which starts at 2 o'clock, which will be on EV manufacturing. Thank you.
Thank you, everyone. Yeah, thank you. Have a good day.
Thank you.
Yeah, hope my group sharing have bring something to you today. Thank you.
Sure. Thank you. Thanks a lot.
Thank you. Bye.
Thank you.
Bye-bye.